This video highlights the Tributary load takedown feature. Visicon incorporates a patented tributary generation and load takedown algorithm that can be used to rapidly estimate gravity loading of columns and walls in Revit, IFC, ETABS, and ADAPT building models. As a first step, larger load-bearing components are discretized into smaller segments, allowing for a more refined load transfer calculation. Next, the discretized components are assembled into discrete horizontal analytic levels. Horizontal analytic levels are then broken down into tributary areas. Each lower column and wall segment is assigned its own region. Load paths are calculated by connecting the topmost components in the building model down to the lowest elements. Load paths are displayed graphically and are an effective communication tool. They can highlight the underlying complexity of a structure's vertical load path. This can be particularly useful when trying to explain the structural design to non-structural engineers. Vertical discontinuities are highlighted, giving engineers quick insight into areas that may require additional review and add complexity to a project's design. The contrasting color coding makes it easy to locate them in large, very complex projects. Using the load paths, Visicon calculates and reports the individual tributary and cumulative tributary areas for each column and wall. The intensity of loading on members is displayed using a heat map. Display individual and cumulative tributary areas in a detailed Excel report. We're now going to switch to Visicon and run through the tributary load takedown feature. We've opened up an ETABS model, but what I'm going to show you applies the same to any Revit, IFC, or ADAPT multi-story model. We're in our Analytic tab. First thing we'll do is go ahead and create the discretized analytic levels. And so here we can see it's gone through, and you can notice that the walls have been discretized into smaller segments and the columns have also been split. Each of these horizontal and vertical elements are now connected into what is the Visicon analytic representation of the structure for load path calculation. As a next step, we calculate the tributary areas. Now we can see that each level has been discretized into individual tributary regions, one for each column and wall segment. So here we're in isolate mode. I can grab, and you can see each of the small wall segments also has its associated tributary. If we switch to home, enable the single level mode, this gives you a better view of what the individual split looks like. Again, you can see that each of the wall segments has a tributary region and the columns also have their own. So this gives you a good sense of what that discretization looks like. We'll go back to the multi-story mode, zoom out, go back to analytic. Next step is to actually calculate the load path. So we've now calculated the load path, and the most interesting thing to begin with is here you see the color contrast where the program has identified all discontinuities. So here the reason this particular tributary is tagged as discontinuous is because this wall rests on it. If we look at the other side, again we have the wall component here that's triggering that condition. Here you have a clear transfer of a column that goes from one side to the other, and here we have the same condition. While we're in this mode, we can also display the individual load paths. So if I select any support, it highlights the tributaries that are contributing to the load at that point. So here we can see it has the transfer, and from that point downwards it takes the path down. It doesn't include any of the tributaries because here we're just going the other way. I can isolate those. I can grab any point at the top. So here, for example, that roof panel has a column. There's a transfer at this level. This particular column then is continuous all the way to the foundation, and then the secondary column has another transfer in it. So there are two ways that you can display the load path: by selecting from the top, or inversely selecting any of the supports at the bottom and seeing what contributes to the load of the column. The last step is to go and do the load takedown. So with the load takedown in this version, it's just calculating and accumulating the various areas. So here we can see which columns are the ones that are most heavily loaded. If we grab one of these columns, go to the object properties, scroll down to the bottom, we can see that that particular column has a tributary area of 375.4 square feet and is carrying a total square footage of 14,933 square feet. When we're done and have looked at the structure, the last step is going to our reports. we'll create a tributary report, run the tributary report, and we can see that it has formatted all of the information in a tabular format. We have the levels. Here we have the tributary areas. For the same columns, you also get the cumulative tributary area that gives you all of the information. Visicon's tributary area and load takedown feature is a practical solution that lets structural engineers and other project stakeholders gain instant insights into their structural models without having to spend hours or days building a complex FEM model. Calculate tributary areas for individual slabs or an entire project. Display load paths and vertical irregularities as a quality control measure or to communicate your structural design in presentations. Prioritize a design team's work by identifying the most heavily loaded columns. Generate loading data in Excel and use it to run your gravity column design programs or to estimate transfer and foundation loads. Thank you for watching our video. Contact sales@visicon.com or sales@adaptsoft.com to request your free intro version.